The broadcast is now starting. All attendees are in listen-only mode.
Well, good morning or good afternoon, APA. This is Chris Kopek, the past president of APA. In our webinar series, The Continuous Learning Continues, this end of the month of July. We had got a great topic here. It was a topic that was presented at the recently completed and very successful Denver conference, and it's regarding the next generation of fault detection diagnostics, facilities management thriving in the age of change. And today we have KGS and Alex Grace, Vice President of KGS, who will be presenting. I'll be jumping in occasionally because there's a number of universities from the University of Arizona, University of Iowa, Western Michigan, two of our past presidents that are currently using the KGS diagnostic system and seeing a lot of great opportunities for savings within their operation. So with that said, this webinar will be an hour long. We'll have about 45 minutes of slides, about 10 to 15 minutes of questions. If anybody has questions, please go ahead and type those in. And as always, we'll have the presentation put on the APA webpage shortly after it's completed, the audio and the presentation. And also remember, you get credits. And so AIA credits, you can use these also for your certification credits too. So with that said, Alex, we sure appreciate you coming back to APA very quickly after helping moderate the presentation in Denver. We thought this would be a great topic for our members and giving back to them some really great knowledge. So take it away, Alex.
Thank you so much, Chris. Really appreciate it, and it's really an honor to be able to do this webinar and talk to you all today. So really thrilled to be doing this. We did have a fantastic conversation in Denver, and there's a lot of excitement, a lot of enthusiasm building just around smart campuses in general. No, it's a big theme and strategic vision for APRA. Heard about some things coming together in terms of really helping universities on their smart campus journey. So really thrilled to be kicking this off, and Chris, certainly we'll be pulling you in here and there. I know you have a lot of experience with this topic, and we've been really thrilled to be working with the University of Arizona. So we'll pull you in as we go through here. And as questions arise, just for those that are attending this webinar, thank you so much for joining. Please do ask questions. Happy to keep this a group dialogue as much as we can. So I'll get started here. So first, I should pull up the continuing education slide. That's a part of this presentation. So certificates for completion for AIA members and non-AIA members are available. So I want to make sure that everyone is aware of that today. So I thought I'd start off this conversation by just discussing the challenge a little bit that we're all, of course, very familiar with in the world of facilities management. So this is some research that has come out from Lawrence Berkeley National Labs, IDC Energy Insights, and others, and just some quick statistics to start off this conversation with, which is that research shows us that 20% of maintenance and energy expenses may be saved by predictive maintenance. We know that this is not specific to higher ed, but just in general, in our buildings, 40% of people tend to be not always satisfied with comfort in their spaces. And the last one I want to really highlight that I think is particularly relevant for our audience here, which is that 80% of equipment actually fails for non-age related reasons. In other words, fails before its time. So a lot of challenges as we all know, when it comes to deferred maintenance and keeping things going. There's some other trends around FM that I think is really driving us towards smart campuses and fault detection in particular. And one of those trends is certainly the challenge that we have around very experienced professionals in our industry that are retiring and the knowledge gap there. And I know, Chris, that's something that you've certainly talked quite a bit about, even as an important theme of your presidency of APA.
And it was, and it continues being. As president, my theme was harnessing and transferring the knowledge. We continue seeing that in all our universities, colleges, and K through 12. Quite frankly, we see it throughout the entire United States. 10,000 baby boomers, 10,000 retiring per day for the next 10 years. And so apprenticeship programs, the ability to harness the big data within our institutions using technology, the fourth industrial revolution, where we're able to take that information and make real-time decisions So when you do lose somebody who has that 30 years experience within your utility plants and your tunnels, you're not going to lose all that knowledge. We're using computers, technology to the ability to capture that, harness that, and then transfer it to additional staff so we can make real-time decisions that have real-time cost savings for our institutions, which is just critical.
Absolutely. Yeah. Thanks, Chris, for covering on that. And I think we'll keep coming back to some of those topics as we go through this. That knowledge transfer and the role that technology can play in that knowledge transfer is an incredibly important driver around all of this. So real quick on the maintenance topic, and we're going to talk about a couple different areas here today. So we'll talk about maintenance, proactive and predictive maintenance, and the role of technology plays there. We'll talk about commissioning and how fault detection is impacting commissioning processes and even turnover from capital construction to operations and maintenance. And talk about a number of different case studies here today and real world examples about how universities are really utilizing and really beginning this technology journey. So real quick, while we're on the maintenance topic, we know through research that the most expensive form of maintenance is reactive. And we also know that our organizations tend to be reactive by necessity. We are used to responding to hot and cold calls, responding to building automation alarms, putting out fires when they need to be put out. We know that preventative maintenance is fantastic and totally essential to be able to have schedule and plan work, and that predictive maintenance or insights through fault detection can actually allow you to do more scheduled and planned work. So there's a topic here we'll touch on energy and the energy savings part of this whole discussion, but also this facilities optimization in terms of where we spend our time is a really important thing here. Every facilities management team is being driven to do more with less, and this is a really important driver of if we know where problems are before they become big headaches, and we're therefore allowed to schedule and plan that work, what is the impact on the overall organization, both from a financial perspective as well as just how much we can get done, right? So we'll come back to this topic, certainly a key driver. Chris, as you mentioned, the fourth industrial revolution is a big topic today. It's here, it's all around. We're going to have more and more and more connected devices, connected assets. The Internet of Things is coming very quickly. And I think what sometimes gets overlooked in that broader IoT discussion is just the fact that we already have a tremendous amount of equipment and devices that are online through the building automation systems. And how can we really capture that data, right? Because there is a tremendous amount of data, and there's a conversation going on across the board in the industry around let's make sure that the data we're collecting doesn't turn into a data swamp. And there's more to discuss on that front. So there's a lot of buzz around creating data lakes or creating the ability to really mine information, mine data to turn it into useful information. Well, let me pause for a second. I thought this quote was fantastic. On the panel that Chris, we were on, Don mentioned this, Don Guckert, the AVP at the University of Iowa and recent APA president. He said, we realized that we were data rich, but information poor. And I thought that was really powerful for a couple reasons. One, the fact that university campuses are tremendously data rich. There's an enormous amount of data that is locked up in building automation, in metering infrastructure, in other data stores. But information poor, meaning it's so much information. How do you really sift through it? How do you analyze it? And therefore the role, of course, that analytics can play in solving this problem. One thing I want to point out, because there was some conversation around this at the APA conference, is around the topic of data normalization. It's a little bit of a chicken or the egg question here, but the point being that you have a lot of data, and that data, we're talking about sensor information, set point information, mode points, etc. That's part of the sequences to command and control equipment. That data tends to be typically not normalized, right? There's different naming conventions, different standards, depends on what programmer did what, even if it's within the same building automation company. As part of a normal fault detection and diagnostics process, that data normalization is inherent. So just a quick comment there before we go forward that actually you don't have to worry about normalizing everything. It's a Herculean effort to do that. and you don't have to worry about doing it in a vacuum. In other words, that as part of the FDD process, this is sort of a standard component. And really, fault detection and diagnostics is all about turning those mountains of data into actionable information that team members can utilize on a consistent basis. So, quick point here on integration. It's always an important topic, which is IT security and how do you get at this data. Another thing I'll point out is that it used to be, so this topic that we're talking about today is around the next generation of fault detection and diagnostics. FDD has actually been around for a long time. And in the first generation, I would say you really had to have the data stored. You had to trend it, you had to store it, and then analyze it. Today, you don't need to do that. You don't need to do any local trending. There's major benefits of storing data in the cloud. It's certainly cheaper to store data in a Microsoft cloud data center than it is in a local environment. And we don't have to worry about the building automation system's ability to actually handle and store that data. So there's a lot of different approaches out there in the industry around integration. Of course, I'm presenting one here, which is how Clockworks does things, which is that you don't need any hardware locally on your network. So IT likes that. There's a software gateway. So picture just a piece of software. It's a Windows service. It can be installed right on a building automation workstation, can be on a virtual machine, but that service is pulling the building automation every 5 minutes and then doing a one-way outbound push to the cloud. If there's one thing you remember from the IT topic here around how do you get data out of your buildings, how do you make it actionable, for the IT topic, it's really one-way data. That gets around a lot of headaches when it comes to IT. And there's a range of course, of building automation protocols that are supported around that. Building automation world has largely moved to BACnet, but there's other protocols supported. Modbus tends to be for metering, OPC for more SCADA environments, OBIX, Native Niagara, and others. So it's agnostic to what type of building automation is there. Wanted to present just a few best practices around FDD. So first best practice is that it should really be able to provide root cause analysis. So what you don't want to do is have a fault detection system that sort of looks like the alarming that you already have in the BAS. You want it to go way beyond what alarming is capable of. String together dozens to hundreds of rules to really pinpoint the root cause of the problem. So simple rules engines, if then type FDD is really again, that sort of previous generation, but now you have the ability to really tie these things together and get to the root cause. Secondly, it has to scale across campus and really be able to provide a holistic solution for universities. And then lastly, the use of a centrally managed library is a little bit of a geeky nuance here, but it's very important. So it means that the diagnostic codes themselves are constantly updating, and this is a shared approach. So it means that if something new gets developed through work with University of Arizona or with MIT or Stanford or you name it, that those lessons learned and those new capabilities are actually passed on to all globally. So in other words, the platform itself just continues to get better and better, and that's an important quality of this category of next generation fault detection tools. I'm transitioning here to a little bit of an important question which always arises, which is, well, what is the savings around all of this? And we can talk about some case studies a little later in the presentation more specifically, but I wanted to give a shout out and a plug to the Smart Energy Analytics campaign. This is a really powerful campaign that's run out of Lawrence Berkeley National Labs. It's funded by the U.S. Department of Energy and their Better Buildings initiative. It's an extremely powerful organization in the sense that they're really providing some very leading research holistically on energy management information systems, which includes fault detection and diagnostics and includes EIS, energy information systems. So right now, this is a slide I stole from them. Thank you, LB&L folks, looking at their analysis of over 94 million square feet of projects. And what I thought was particularly powerful about this research was that it showed the long-term effects. So because a lot of driver around the use of fault detection is moving from one-time energy projects to really a continuous improvement process or ongoing commissioning enabled tools. So what they found, you can see here, is that in the first year, organizations had a median savings of 4%, and those savings actually climbed quite substantially over time. 11% by year 2, 13% by year 3, and 19% by year 4. That's relative to the year before they began this journey. So it speaks to the value of a continuous approach, and that it's not really a tool set that you can kind of do a one and done energy project with, because valves never stop leaking, dampers don't stop sticking, sensors don't stop degrading, or as we often say, the interesting thing about low-hanging fruit is that it really never stops growing. And this is some powerful data behind that statement. So I really encourage you to check out the Smart Energy Analytics campaign if you haven't already. This is a slightly different view. So looking across multiple years together, people who have used FDD for different time frames, and you can see a median savings there of 7% from their research. So again, that's what the website looks like. If you just want to make a note of that, they do interesting case studies. Actually, University of Iowa won an award last year, so their case study is under here as well. I believe it's under technical assistance, if I'm not mistaken. So fantastic organization, and you can get involved there if you're interested in doing so. Okay, transition a little bit from some of those points to talk about how FDD and fault detection diagnostics really brings multiple stakeholder groups on campus together. So whereas tool sets in the past were maybe siloed through certain use cases, there's really an opportunity today to have that one source of analytical truth that multiple different groups can use for different reasons. So we see university maintenance and controls organizations that are getting ahead of problems, that are understanding where there are priorities relative to energy, but also maintenance and comfort, again, being able to plan that work. We see energy engineers and utilities groups using the tool to be able to look at a top-down perspective, so to be able to benchmark buildings, to be able to look at the energy consumption, normalized, as well as key performance indicators. So I'll come back to that a little bit. Energy key performance indicators like heating efficiency, ventilation efficiency, cooling efficiency. And then commissioning teams, whether that's in-house teams or outsourced vendors. There's a lot to be said there, so we'll come back on that. But having fault detection diagnostics and technology do some of the heavy lifting of the commissioning process, and again, being able to transition from commissioning as a one-time event to a continuous process is really what that tends to look like. Here's some really powerful data that I want to bring up. It's a university example of being able to shift work order volume to predictive maintenance. So this is a university that was really able to track their corrective actions, their corrective work orders, and their fault detection driven work orders over time. So it's a snapshot here that we're looking at of 3 quarters. And what's a little bit hard to see, but what this represents here is actually 24% of work order volume becoming out of fault detection. So shifting organizationally from reactive to predictive, and then being able to quantify what that really means. So just to drive that home a little bit, if we think about a typical hot call, let's say we go out, we look at the thermostat, we try to figure out where the problem is. We might get an additional call and go back and actually get into the ceiling and see what's going on. But we think about the investigation time it takes to really find the root cause. Now, if we shift to a predictive process where we can plan that we know these 3 boxes are having consistent problems, we know that they're more important than the other 4 issues that are also happening on that floor, so we want to address it first. And we know that the reason that the air temp is higher than its set point is because it's a supply flow issue, so we want to look at the performance of the damper. And we want to check out the reheat valve because it appears that it's actually leaking by. So maybe not the best example there for Arizona, but for those folks on the line that have more reheats, that might resonate. So being able to, again, know where the problem is before we go out and fix it means we can get more done. And there's an overall initiative there, some really powerful data coming up around the results of that predictive approach. So real quick, we talked about energy performance indicators. There's a lot of power in being able to connect the what I call top-down analytics. So how are my buildings performing against their baseline? How are they performing against each other? With the bottom-up analytics, the fault detection. So the obvious question comes up if you have EIS alone or energy benchmarking alone, is okay, if I know that my building is using 5% more energy this year than it did last year, that's really important information, it's valuable information. However, where do I begin? How do I know why? Where is the problem, right? So being able to drill down from the high level benchmarking into the individual equipment and systems that are driving that indicator or driving that energy performance in the wrong direction, that's a very powerful thing. I won't spend too much time here, but just give you a taste. This is a very powerful flow chart. Comes from MIT. They presented it at the Building Commissioning Association in their use of fault detection and how they're doing this. So post-occupancy commissioning strategy with fault detection. So again, won't dwell too much time here, but the main point is being able to insert fault detection in that commissioning strategy, whether it's retro commissioning, whether it's new construction, and how that all flows into this bottom box here of a continuous approach or the ongoing commissioning process. You know, on that new construction front, Chris, if you don't mind if I pull you back in here for a second, University of Arizona has been, I know you've had some really interesting thoughts around that, around new construction.
Well, it's not just new construction. You were talking about commissioning of buildings and then the deferred maintenance. And no matter what we call it, if we call deferred maintenance, really what we're trying to do is optimize our buildings, and we're trying to increase our energy efficiency. We're trying to take aging infrastructure, and it's affecting all of us. Aging infrastructure at the University of Arizona alone, we have 2.5 million square feet right now that fall within that 50 to 60 year range. Air handlers on average are built to last for about 27 years. And we have gotten so good with our staff that we've kept them together twice the period of time, 60 years. If we look fast forward right after World War II, or right after World War II, we saw such a great growth. When we look fast forward at the University of Arizona, in 10 years, our buildings that fall within 50, 60 year range will be 5.5 million square feet. And that trend continues for the next 30 years. Our buildings are aging out. We have great opportunities to optimize the efficiencies of the building. Funding is always the challenge. And so that's a whole nother webinar of how do you get creative and get funding to address these issues. But once you do, we then have taken the KGS system and put it in our new buildings, our high-tech research buildings that are energy hogs. They use a lot of energy. And so the ability to be able to make sure we can read those new buildings right off the bat so they stay consistent with how they were designed is extremely important in saving utility costs. And again, it's not just now. This will continue to be a challenge for all of us for the next 10, 20, 30 years.
Wow, absolutely. Very powerful. Thanks, Chris. I'm going to bring up a few quick case studies here and then actually go into a live demonstration of what some of this actually looks like in a little bit more technical detail. So this is a powerful campus example of saving over $1 million across about 90 buildings with fault detection running annually and pretty extensive measurement and verification here to meet sustainability goals, to provide access to data across multiple stakeholders. Again, those three areas: mechanical controls, more energy engineering, and commissioning. And I want to bring up this for a second. This was presented publicly at the Green Build conference, the USGBC conference, and it was MIT's view of monitoring-based commissioning as being the most cost-effective approach to energy and carbon reduction. Now, we are talking about low-cost, no-cost measures, so that's not totally a surprise, right? But a very powerful statistic nonetheless. So This is looking at this chart here of all the different energy type projects on campus. That's lighting, mechanical, equipment upgrades, insulation, and other types of capital projects. And you see the simple net payback here on the right. So we find that organizations that are very proactive are looking at this whole technology evolution holistically and how it benefits the organization, how it allows you to do more with less, how, as Chris said, it helps address some of the knowledge transfer challenges that are occurring. But at the end of the day, of course, we all know it needs to pay for itself at the same time, and this is just some very powerful data there. So their implementation of monitoring-based commissioning produced the greatest amount of energy and carbon reduction at the lowest payback. So some really powerful data when you're making those types of financial arguments to the stakeholders that you need to make it to. This can help provide some ammunition. And this is over a 3-year period here.
You know, Alex, if I can jump in here for a second on that last slide.
Please.
When you look at the payback on that, and if you can pull it back up, if we look at our buildings, as we were talking, the buildings aging out, roughly over 50% of what's aging out is our air handling systems. And the ability to be able to read those systems when they're not performing as they should is just critical. And as you have a simple payback here of 5.6 on the mechanical systems, well worth the investment to make sure that you can read real-time data and then make the corrective action in a very timely fashion. It has great payback for you, as you see on the chart here. Thanks, Alex.
Thank you. Thanks for chiming in, Chris. Yeah. Excellent. So I'm going to go ahead and transition to a live view here. And if there are any questions appearing, happy to take those when appropriate as well. So let's just do a very quick snapshot here. We have about 15 minutes before the overall Q&A session here, and I want to make sure, of course, that we leave time to that. I'm sure Chris will keep me honest. So here's a window into what this all looks like. And of course, this is essentially you have a campus map and buildings color coded by how many faults and the dollars associated with those faults. So it's really an operational snapshot. When there's 90 buildings, let's say, that are on the platform, being able to look and see where the problem children are and where more time and effort should be devoted. So that's a powerful view there. You know, one point with all this that I think is really important to note is we talk with a lot of facilities organizations, of course, spend a lot of time with higher ed leaders, and we've definitely yet to meet a team that is looking for another to-do list. That's for sure, right? I mean, we're all slammed. There's always too many things to do in a day than we have time for. So at the end of the day, this whole world of fault detection, of turning all this data into actionable information, it's all about prioritization. It's all about what should we really care about most from a manager perspective. Where should my people be focused to drive the greatest impact to the university? And from a risk perspective, where can we be focused to make sure that we don't have unforeseen events that have negative consequences, whether that be to a research lab environment or simply student comfort. So from an everyday perspective, most of our super users here, folks that are really in this tool on a daily basis or a weekly basis, depending on their workflow, they jump right into the diagnostic tool here. And this is that list. You could think about it as a punch list. It gets generated every single day that says, what are my top priorities? So right now we're looking at results from yesterday. 5-minute interval data, temperatures, pressures, flows, set points, modes of operation, all crunched down every single day to say, where are my priorities? I want to point out that it is a daily batch analytics run. The reason for that is this does not replace any critical alarming that you already have in your building automation system. We don't want to know that a valve's been leaking for 5 minutes. We want to know that it's been leaking when it reaches a threshold that it's really worth our time and attention, and that it's more or less important than the other range of possible conditions that are happening on campus that we want to draw our team's attention to. So this is just a demonstration here. Again, 24 hours of the data, top priorities sorted by energy. So top one on the list here, I can see simultaneous heating and cooling. I can see return relative humidity is higher than its set point, that there's a leaking heating valve here, and a supply temperature reset error. In other words, there had been a reset program to drive efficiency, and that reset is in fact not being followed. So that points to the one-time, let's say, project or commissioning or optimization work versus a continuous approach. We know that all it takes is one keystroke to override that sequence. And maybe it was a good reason, maybe it wasn't, but we want to bring it to attention. Now, I'll point out, as we mentioned before, that one of the qualities of next generation FDD is the ability to string multiple findings or multiple rules together to get to that root cause. So what we don't want is to have simultaneous heating cooling be one line item, to have return RH higher than set point being a second, leaking heating valve to be a third, because it means that you have really a mess of individual fault findings that become hard to prioritize. By stringing it together, it allows you to get to an accurate cost. So for the fellow energy nerds in the line, I say that term fondly, there should be some appreciation there, right? So the same energy associated with the leaking heating valve is the same excess kBTUs associated with simultaneous heating cooling. So we want to make sure to not double and triple count. That's an important thing relevant to tying these issues together into one hierarchical diagnostic or analysis. So these analyses look for a range of conditions. If you hover over, you see that. And that also provides some positive validation. So on this one here, AHU fan is a large block of sophisticated diagnostic code that looks to say, are there any fan speed feedback issues? Or are there any times where there's no airflow, where the fan's on, or where there's sensor drift occurring, or abnormal fan currents, or short cycling, or you name it? What's been found here is that occupancy is actually not compliant with the desired schedule. Or that there's a minimal load across the chilled water loop, excess mechanical cooling when we could be using outdoor air, and down the list. So these are sort of common, typical top examples related to energy to be able to pinpoint what's really going on here. Now, if we click into one of these, we get a full report. So I'm going to go ahead and do that now. And we can see that each of those problems identified has a list of possible causes. So this plain English output here is automatically generated, and it's to really save time. So we have a lot of maintenance leaders that will tell us that, you know, even if I have a guy with 25 years experience on my team, having that list of possible causes does save us a lot of time. So there's a dollar value here calculated from the heating side and the cooling side. And why is this issue happening? Well, the valve might not be seating properly and is leaking. In fact, I can see that is the root cause because it's listed here as well. How do we know that the heating valve looks like it's leaking? Well, it says that the average temperature rise over the coil while the valve was closed and the fault was occurring was 13.2 degrees. So where is that temperature gain coming from across the coil if there's no hot water going through it? And the possible cause here, direct resolution, either the valve is leaking or stuck, could be an uncalibrated or malfunctioning temperature sensor, or a controls error. Either way, worth investigating. And I jumped ahead of the return relative humidity issue here. It might be causing comfort issues. For certainly a range of possible mechanical problems here that could be leading to that. And then that our reset is not being followed. So we had a return error reset schedule. That's not being followed. And then again, below all of the trended information. So at the top here, when were these problems occurring? In this case, 24/7. And then a lot of trend data for those that are used to looking at information and want to sink their teeth into what's happening here. So I'm just going to jump to the coils themselves real quick and just illustrate that. So the valve position here is this blue dotted line. That's at 0%. The mixed air temp is in green. And the temperature after the coil here in red, above. So our air temp is coming up from the mid 70s to the mid 80s. That's that 13-degree heat gain. On the next graph here, the cooling coil is opening. That's that blue dotted line again. It's doing exactly what it should do, bringing the air temp from the 80s down to a nice, perfectly comfortable temperature of 54 degrees. So if you look at this example, no building automation alarm is going to go off here because we're still meeting our set point. But in order to get it there, we're doing a lot of heating and doing a lot of cooling unnecessarily. And then again, for the energy folks, actually quantifying the actual versus the ideal heating rate and the actual versus the ideal cooling rate. In other words, how much heat should you be using to meet your supply air temperature, and how much heat are you using, and likewise on the cooling side. And that's how the energy calculations are actually done here in terms of the measurement and verification. So jumped in a little bit of detail there. I'll zoom back out a second, look at the overall list here. So far, we've been talking about energy. I'm going to jump to the other priorities here. For a number of the teams that we work with, energy is actually not the top priority. So if I click on comfort here, I'm going to get a very different type of list. And again, this is what's affecting our ability to meet space temperature and humidity set points in our zones. So pulling up the range of VAVs or fan power boxes that may be having issues there with supply air temperatures being too high or too low, with supply flows being off, that kind of thing. Okay, so in the interest of time, I won't spend too much time here within the diagnostics. The maintenance and comfort prioritizations are certainly important, and I'll just zoom us back out a level to say, what do you do with this information? How do you actually make it actionable? What does it look like with your teams? So all of this list of problems here, you can actually create what we call tasks. There's a one-to-one relationship between a task and a work order, and it's actually possible to connect the dots. So one of the things we promised as a learning outcome of today was the concept of future-proofing your analytic strategy. And really what we mean by that is that it's very important that next-gen FDD really has APIs. Maybe some of you are more or less familiar with that term, but it's the ability to connect multiple software systems together. We firmly believe there's use cases, there's things that you may want to do with this data and with this information 5 years from now that we haven't thought of today. So it's really important that interoperability occurs and that you have the ability to be able to tie multiple systems together over time as it makes sense. And one of the most obvious use cases there is to tie work orders together so that when you create a task, it creates a work order. When the work order is closed, that information gets received back. I just transitioned here to a sample report to illustrate that a little bit. So there's with that work order data, you can start to track the impacts of that predictive maintenance activities that we were referring to before. So I'm going to show some pretty interesting information here. I'm going to pull up a report. What we're looking at is actually Power BI. It's a business intelligence dashboard. There's an API that's pulling data out of that Clockworks platform into this flexible reporting engine. So I've gone from the weeds of the leaking valves and the stuck dampers up a level to really an executive level summary of what's happening on campus. So the first thing is what's really been identified and how does that break down by building? Where are we finding the most amount of issues? And if we click on buildings here, we can actually see specifically what's going on and everything dynamic here in terms of the excess cooling use, electric use, heating use that are being identified. Here's another way to look at that, which is what buildings on campus have the most potential for savings. So I'm going to point your attention to this list here on the left because this is pretty interesting. And talking about, Chris, where you're referring to there around deferred maintenance before and the challenges around equipment upgrade, this becomes some very powerful operational data to roll from the fault detection up to a level where capital planning and decision making can really occur. So what we're looking at is what equipment has cost us the most amount of money over time from an excess energy perspective that we've been performing maintenance on regularly. So we're looking at a date range here of about a year. And we can see what's been the most costly equipment with links into the diagnostics. So this becomes powerful to inform that capital planning process and figuring out whether we want to look at more extensive upgrades if there's persistent maintenance issues that keep coming back. You know, how do you take all that data and bring it up to this level where decisions can be effectively made?
And so, Alex, if I can jump in, you look at we know we have buildings that are old. We know they're not as efficient as they need to be, and so it's that nice fine line. It's having the KGS system on our current old buildings, but then also these newer buildings. And maybe you can discuss that, the benefit to having you go ahead and redo. You got a complete building. You don't take the structural of the buildings back in 1940s, 50s, 60s. They build them like tanks. I mean, they're beautiful pieces of architect. It's mechanical systems failing. Right. And so once you updated those systems, or you have a new building, what's the benefit of having KGS system on those new buildings too? High-tech research, for example.
That's a great point. Thanks for raising that, Chris. So, I think the first thought that comes to mind is in the session that we had last week in Denver, Devon Miller made a really interesting point. Devon's a commissioning specialist and leader at Western Michigan University on Pete Straza's team, and a fantastic user of this. And he made the point that they were blown away. We actually, it was the first building we did there at Western Michigan. They gave us a LEED Platinum building that was brand new and put Clockworks on it for commissioning. So that was a challenge. I'll admit I was a little nervous there as to what we'd find in terms of showing value. And Devon was saying they were just blown away by the amount of issues that they found, even on a LEED Platinum building. And this is one of the reasons that LEED has been moving towards the existing building commissioning requirement for those of you that are doing LEED certifications. And the reality is, in the post-occupancy, there's a lot of things that do get found, right? Or oftentimes commissioning gets done at the end of a process. You're rushing to get students in the door, rushing to get researchers in. And after people come in, some of the usage change, things get overridden, things start to get out of whack pretty quick. Probably the biggest driver that we've seen for fault at detection on new construction is really the impact this has in catching warranty items. So from an owner perspective, being able to identify where there are warranty issues and be able to, frankly, hold vendors accountable, that's really a core benefit. And make sure that these investments that you're making in new and efficient systems are actually performing the way that you expect them to. And I think there's more and more of a recognition in the design community that's really important, because they spend a lot of time doing beautiful designs, but they don't always have visibility into how they're performing. And having a tool that really ensures the performance from day one is very, very powerful.
And Alex, I think that's a great point, because as you look at it, not only our institutions are losing a huge amount of folks due to retirements, all our contractors are in the same boat too. And right. So where are they getting their staff in the mechanical, electrical, plumbing field? And to have this ability to be able to detect if there is an issue can have great cost savings. Thanks.
Right. Absolutely. Thank you. Okay, so just real quickly here, just some other interesting reporting ideas around all this. To think of it, really, this is about thinking of when you have fault detection in place, what type of analysis can you really have at a system, at a team level, to understand what's going on, and how does this inform overall operations and the vision of your facilities management? So being able to see what work do we have in process out of all this, what are the savings associated with that. So this is a portfolio. We're looking at 85 open tasks. So far we saw how much savings is out there for us to achieve. Here we have 473,000 savings that's in the queue. So we're working on this, it's in progress. And then how much did we actually complete here? Completed 59 tasks, saved almost $200,000 as a result. So one of the things that we often see gears turning on for team leaders is having financial visibility, of being able to make arguments that they just weren't able to make before because they didn't have the data, to be able to say, when we're able to get to these things, we're able to fix these problems, look at the results we're able to have. And that's been powerful too. And I think I've just been blown away through my time over the last 5 years of participating in APA in particular, how there's that constant vision of having facilities leaders not just be at the financial table, but really setting the table. And I know I've heard that term before, Chris, and having this type of data to really back up, that's crunched for you automatically every single day, thinking about that role that plays in helping set the table. Okay. I'm going to just jump back here for a second because I'm eyeing the clock, and I know we want to open up for questions pretty soon here. So I'll just close for a second by just laying out a little bit of a vision, which is that we firmly believe that within 5 years, all large portfolios of buildings will have analytics in them, that this wave is coming, this fourth industrial revolution. It's very powerful. There's so much data that's simply locked up that can provide, that is waiting for business value to be created from. And there's really a transformation underway in the world of facilities management towards this data-driven and predictive maintenance model. And I think in terms of takeaways, you know, the old adage, how do you eat an elephant one bite at a time? There's a tremendous amount of lessons learned at this point from universities. Certainly, University of Arizona is a fantastic leader on this, and others mentioned Iowa, MIT, and more. Western Michigan, certainly. And just some advice, of course, would be to mitigate risk, but most of all, to really start. You know, to not let this be overwhelming because changes are occurring. I know that was a topic at APA, certainly, that change is happening so quickly that really the most important thing is just getting started. And there will be a learning process, no doubt, over time, but the best way to learn is to have a phase one approach that tests, validates, mitigates risks, and expands as you can make those business arguments to particularly the financial stakeholders. And I know that APA is launching an initiative on technology strategy to really help prepare and continue to inform members around smart campus technology. That it's really a big focus moving forward. So that's very exciting.
Well, Alex, we have several questions. Are you all set with the slides?
Absolutely.
Well, I'll tell you, the data is showing that by 2030, the McKinsey Global Institute, Wall Street Journal have quoted this, by 2030, 13 trillion in additional economic output worldwide will be tied into the AI and the ML, machine learning. 25% of the firms have implemented currently. 75% will be implementing in the next couple of years. And so what you've been talking about is spot on. This is coming. So here's the challenge for everybody on the line. And Alex, how do we address it? You have an aging workforce. Not all of them are as computer literate. Not all of them will embrace the change. You said it's not another to-do list. Nobody wants paper just getting spewed out each day. How do you tie the two together of this new technology and in some cases the aging workforce to make sure that they're blended into one? What's the strategy?
Wow, fantastic question. Really an important one, enormously important one. So I think that the first thing that comes to mind is that what we've seen time and time again, that having a champion is really critical. So for the other senior facilities leaders on the phone, you know, thinking that through as you think about your teams and your organizations, who is best positioned to, you know, someone who's excited about new technology, who is used to doing, let's say, commissioning or trend analysis, or an experienced maintenance technician that is open, you know, to new approaches and new things. That's I think fundamental. And then what we've seen is that champion really needs to have some internal credibility as well, right? So to be a leader inside to help drive this change. And even as simple as saying, we're going to meet and spend 1 hour a week looking at this. And we're going to create, and we're going to set a goal. So we found that goal setting to be extremely important. And say there's a certain amount of work orders we're going to create every week based on what fault detection is finding for us. And we know over time that's actually going to save us time. It's going to, you know, no question, there's going to be more work orders up front. But those are problems we're going to have to address at some point anyway in a reactive fashion, right? So what does that save us down the road? We've seen other organizations that will say we have our head of controls, head of maintenance, head on the energy management side, and every morning we're going to get together and we're going to spend just 20 minutes. And we're going to look at that list from Clockworks and identify what are the issues that we want to send out to our teams that day to tackle. So I think bottom line across these different approaches, and we've seen leaders and those champions come out of the controls organization. We've seen others come from commissioning, and others come directly out of the mechanical side and the maintenance side. So I think it works different for different folks, but the bottom line is having someone that can embrace change, that can start to really be a champion internally and set an example.
That's excellent, Alex. And it also ties into our younger professionals in our industry. As we're getting younger professionals, I'll use a case example here at the University of Arizona. We're looking for those who have the passion, who have the knowledge and expertise, and then we groom them further because they're big champions to go ahead and take this. You brought up a great point, Alex. It's communication, 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 and touch base a little bit more on that, because it's not just sending out an email. It's not sending out a list of additional things to do. Communication is critical. I believe you mentioned about whether it's a daily meeting, weekly meeting, to share the information that the sensors and the artificial intelligence will allow us to run our buildings more efficiently. Comment on that a little further.
Yeah, absolutely. The communication is totally critical, and I think, and also from where we feel best, where I feel best, where I sit at KGS Buildings, is when a client tells us, we really feel that you become an extension of our team. So one thing I didn't mention before that is really important as part of this next-gen FDD vision that I'll just comment on is that the tool needs to be fully supported, and you need to have a vendor that stands behind the accuracy of the analytics 100%. The biggest challenge historically with this whole world has been no one wants to chase false positives. So making sure that the data is accurate is critical. And then back to your point on communication. So that was the first thing that came to mind, is communication with the vendor that is setting this up, and that it's fully supported, and that the training is really there. You can't overlook the training aspect with this, that people have support, that they have a phone number to call, that it's not a help desk, and that they know there's an individual that can really help guide them through this process so that it's not overwhelming. We have to make sure it's not. On the communication front that you mentioned, I think cross-team communication is so important, and we've seen that this becomes an interesting way for that communication to occur naturally. So when I mentioned that example, actually it's from the University of Iowa, of those 3 different groups getting together daily, we've seen that conversations occur that wouldn't have normally occurred because of what the analytics are finding. So in other words, simple things like, we notice that we're operating our economizer sequences in this building differently than we are in these 2 buildings. What should be our standards? What are we finding to be most effective? So, or standards around set point compliance, or standards around scheduling. How are we doing morning warm-ups? How are we doing optimal start-stops? Are we implementing resets systematically? So elevating some of those discussions with real data to have conversations across those different stakeholder groups that you have internally, as well as the other one I'll mention in terms of different stakeholder groups is really back to that new construction to O&M process. Because we all know that there can be a lot of, let's say, interesting dynamics there, right? In terms of how that handover occurs, or sometimes operations and maintenance feeling like they got a new building dumped on them without much communication. So again, having a commissioning agent, having a part of that new construction process, using fault detection to make their process more efficient, rather than doing functional performance testing on 20% of the boxes. They now have a tool that's looking at 100% of them every 5 minutes, pointing them to where the problems are. So making that commissioning process more efficient, but then having that same set of data be transitioned to operations and maintenance, so that everyone's looking at the same information from the beginning.
Excellent. Thank you, Alex. Hey, I want to give a couple shout outs. We got some great folks on the line, just hundreds of people. Lisa Potter, been a strong supporter of RMA and APA, along with Tim Dobson. It's good to see you on the line. My friend Dale, back in the East. Good to see you on the line, Dale. Missed you recently at the APA conference. Coming back to the topic, though, Alex, one of the items, you talked a lot about the mechanical systems. We're talking sensors. What impact does that have on space planning? And space planning, what impact would that possibly have on custodial if we know that the room is not being used as often? Possibly cleaning schedules are changed, then you don't have to clean it so frequently. Can you talk about space planning and the sensors?
Yeah, absolutely. That's an exciting area of how this is all being extended. So space planning systems themselves, I think are it's a little bit of a separate category. We certainly don't do space planning specifically. However, I think one of the important points that I think your question is leading to is how do you make sure that all of this is extensible to new use cases, to new sensing that may be existing in the future as sensing becomes extremely low cost And I think that piece is very important. So having an analytics platform that is extensible, that as you have new data sources in the future, that you can pull that data in for those new types of use cases. Just some examples from our side, not exactly with the ones you mentioned, but we're seeing, for example, we started looking at processed water systems in lab environments and wastewater treatment and new areas that weren't focuses of concern for us, but it's always client driven. So a client says, hey, we have this other system here, or in the future we may have a client that says, hey, we just put a bunch of sensors out there, we want to look at our custodial planning, we want to create a custom dashboard to be able to do that. Is that something that you can work with us on? And the power of the shared library there becomes very important, because the fact is there's a lot of commonalities, right? It's not that the use cases are so unique that others don't want to do it. So this powerful approach of this next gen FDD is having a shared library, so that when those use cases appear, when you do new analytics around sensing, or you name it, the University of Arizona, that others benefit from that, and vice versa. So that if a new use case comes out of University of New South Wales in Australia, or Stanford, or somewhere else, that there's that shared approach where the code sets can be applied to all. So it's a nuance there technologically, but I think it's important as we talk about the future and where this is all going.
Excellent. We have a few more minutes. We got a lot of questions coming in. Go ahead and send the questions in. This day and age of getting systems hacked, can you comment a little further on the IT security of the sensors and AI?
Yes, thank you. The security topic is extremely important, and I should have mentioned that before, so I'm really glad you brought that up, which is that I can't recommend enough having an IT stakeholder involved early in this conversation. It's actually a very easy conversation in our experience because of that one-way outbound push that I mentioned. That is the most critical thing for IT. They want to make sure that the data is encrypted and that it's going one way. It's so important to share documentation though early on with IT stakeholders. From our perspective, making me chuckle a little bit here, because we have a defense contractor client where we literally have ex-admirals and generals that are going through a cybersecurity review on Clockworks as we speak. So very much on my mind lately, because it's going through the ringer. So cybersecurity reviews are standard. They're important. IT should certainly be involved early to make sure that they're comfortable with the approach.
Well, this is going to be another webinar in the future. We'd like to hear how the results come out, just the security of the systems as a whole. As we wrap up, we've talked about our aging building infrastructure. We've talked about the benefits of the system and sorting through the data to provide actionable paths, to reducing time to respond, the predictive analysis, HVAC optimization. Do you have any final comments that you'd like to share with us as you've talked about proactive versus reactive?
No, I think that really.
Let me ask another question. The whole system is based on being proactive, seeing real-time issues in a building and addressing it. The value of a commissioning team, Alex, can you comment on that?
Yeah, absolutely. So as we were talking before about how different stakeholder groups get involved, and some have that champion come out of commissioning, some have that champion come out of maintenance. So there are some different perspectives and approaches there. And I think one size doesn't quite fit all. It really does depend on the nature of the organization, how much commissioning resources you have in-house. But commissioning is a great place, certainly, for this to exist. However, we want to make sure that it's not siloed there, and that it goes between commissioning and operations and maintenance. Again, that those multiple stakeholder groups are involved. But the commissioning skill set lends itself really well, of course, to being able to leverage this type of technology effectively. And I think, just kind of closing here, Chris, the biggest thing I can say is it's an exciting time, and we want to strike a balance, but really put it out there that the best advice is just to start. That at the end of the day, there's a lot of best practice here, but there's also a lot of differences and nuances within all of your facilities management organizations, and just beginning and having lessons learned internally as you evolve through this whole journey is important. But the only way to do it ultimately is just to get started and see how it best fits your organization, and share information with others that are on this path as well.
Well, Alex, we sure appreciate your time. We're up to the time now of the webinar. And as always, a great, great topic, forward thinking, looking ahead of what our buildings are going to look like, not only today, but the impact on our facilities staff and how the facilities leaders will be leading the universities and driving down cost as we're all trying to save dollars. The KGS system is very helpful. Sensors in the buildings, real-time data, harnessing that information, and then making sure we're using it. So as you said, Alex, the data swamp, we're getting through the swamp and we're making actionable decisions immediately that have huge benefits to our research buildings, our students, faculty, staff, animal research areas. So Alex, we sure appreciate you coming, taking time, especially seeing that you were just at our APA International Conference. We appreciate your support of APA. We appreciate you taking time to do the webinar for our members. Remember, again, you get certification credits for this. Billy will go ahead and get this. Thank you, Billy, for helping coordinate this. Next month, right in the middle of our monsoons and hurricanes, we're going to be talking about water damage restoration, preventing mold in the buildings. We'll have Darren Foyt from Belfour. We'll be discussing on August 29th, looking at our buildings. Hopefully it's going to be a mild season, but we'll see how that turns out. We go into September, we'll continue with the codes and standards. We're then rolling into October. Johnson Controls, big supporter of APA, will be here supporting us with a webinar on Halloween Day. And then as we start looking to the winter months already, we'll be looking at our gas purchases again. And what does that gas market look like coming into the winter months? With that said, Alex, thank you very much. We appreciate KGS very much. We appreciate all your support here. And thank you, APA. We appreciate everything. Really appreciate everybody who tuned in today. And we look forward to seeing you next time. Take care. Alex, thank you again.
Thank you so much, Chris. Thank you everyone for listening. Appreciate it.
Take care.